All right, here we go. Now you've finished 1301A, you want to do 1301B, and this is adding a time delay. So make sure that you watch the two time on delay and time off delay videos that I put together that kind of explain the functionality of each timer. So we're going to talk about how you can utilize a timer in 1301 to keep the operator from being able to select uh, a different direction or even the same direction in this case for so many seconds to make sure that our start switch is coming back into play. So we're going to use a timer to do that. Now you have a couple of options, and I'm going to talk about both of them here. And we'll go ahead and download and see the outcome. But what we're actually talking about here is this this little explanation right here. And what it's saying is part 2 or part B is going to be reversing the single phase motor. We need to wait for that start switch to engage, and we're going to use an 8-second timer to take care of that. Okay, so let's look at what we can do as far as timers go and how we can utilize them. Okay, so I'm going to go ahead and I'm going to add a new rung here. I'm going to put in a set of contacts, and then I'm going to click on my timer counter tab. And the first thing I'm going to click is my time on delay. Okay, so here, a lot of students get very confused on what to actually time. And I think sometimes students are overthinking it. What are we timing? We're timing whether the motor is running or not. What tells us whether the motor is running or not? Now, some students might say the output being on. Well, technically, that does not tell us that the motor was running, because what happens if somebody pulls the relay out? That means if they energize that output, the motor never did start. So what actually tells us whether the motor was running or not is the set of contacts we get back from CR1. So that's our I colon 0.0/7. Okay, so in the case of 1301, we called those MC underscore stat. Okay, so those status contacts are going to be tested by this instruction and tell us whether this is running or not. Okay, so if the motor is running, this timer is going to time. So we actually don't want that, right? We want it when the motor is not running. So I actually drug down a improper instruction here, but it just gives me an opportunity to show you how you don't have to delete this, bring in another instruction, and then change the instruction. We can change it right here on the fly. So I have the focus on that instruction. If I right mouse click, if you notice halfway down here, there is a option called change instruction type. And if I click that, it actually gives me the 3-letter acronym for the current instruction. If you remember, we've only really talked about, as far as simple test instructions, the XIC, examine if closed, and the XIO, examine if open. So right now we're looking at the examine if closed. So if I just come here and change this to the letter O, it's going to change my instruction to the opposite instruction. So that's a way of quickly changing what type of instruction that you have there. Okay, every once in a while you're going to select the wrong one. Instead of having to delete the whole thing and then putting another address assignment on that, it's much faster to just change the instruction type. Okay, so what we're doing here, as soon as this stops, those are going to open up, and this is an examine if open instruction. So once they open up, this will get logical continuity. When that gets logical continuity, this will start timing. Okay, so we need to give a register for this timer, and I'm just going to go to the very first one, T40. Okay, and I'm just going to call this motor timer. These are not listed on the sheet. This is kind of up to you. And MTR, TMR. Okay. Okay, we're always going to pick a second. And then our preset from our sheet, I said we're going to use 8 seconds for our time delay. Okay. So what this is going to do is we're going to go ahead and we're going to look at the different bits that are associated with this. So this is almost directly like what I did in the relay. This is directly like what I did in the time on delay video, but we're just going to do it again for repetition and to help the student understand. So I'm going to put some rungs in here that are going to test our 3 output bits that we get. Okay, so this one I'm going to put T40 timer timing. Okay, this one I'm going to put T4 :0 / done DN. Okay. And then this one here, I'm going to put T4 :0 / enable. Okay. So we're going to look at those. And I'm going to tie this one to the yellow light, which is O:0.0 / 0. Okay, so this one's the yellow. I'm just going to say light. Okay. And this will be O:0.0 / 1. And this will be the white light. And this one will be the blue. Okay. All right. So now we're going to go ahead and download this. I'll go ahead and test for any errors. Don't have any errors. Okay. Okay. So now we're going to download this. I'm going to come here. I'm going to check my program and download. Before I go online here, you're going to notice this is going to be for a motor that's not running. Well, technically our motor is not running now. So as soon as I download this, I want to go to run. It's going to start timing here. See it timing there because my motor's not running. Okay, so I have a yellow light, which is on during that time period. And then if you notice, it went off. And then my white light came on because I'm done. And my blue light stayed on because I have run continuity. So we don't have a program that I can actually start and stop the motor, but I can manipulate it right here on the relay. We have this little gate that I can manually open it up, and that simulates some external device starting the motor. So now with the motor started, of course we have the green light because that's wired external to the PLC, and that's saying that we have 120 volts going to our theoretic motor. We don't actually have a motor wired to our control relay. And that motor, as long as it is running, we don't have any of our bits set on our timer. But watch what happens as soon as I stop the motor. I get the yellow light immediately because that's when the timer's running and we have the enable bit. So after the 8 seconds is complete, then I lose the yellow light and I get the white and the blue lights together. The white light is signifying that we're done, and the blue light signifying that we still have run continuity going to our timer. Okay, so look at those output bits and look at the one that is on during the timing sequence and how you could use that to disable the starting of the motor again for shop job 1301B. I hope that helps, and we'll see you in the next video.